So what happens is we get to a point where we get quadratics that aren't factorable. I haven't given you any yet this year. I've given you a lot of quadratics, and I haven't asked you yet to solve any of them that are not factorable. It's always a matter of two sets of parentheses, put in your little x's, one positive, one negative. So what happens when that fails? And that, of course, is the vast majority of the time, honestly. The factoring is only going to work in very certain sort of specific instances. So hence the quadratic formula. And the quadratic formula isn't the be all end all. The thing about it is it always works. And like, I mean, literally always. If you have an equation that's a quadratic, x squared, no matter what the other numbers are, it always works. There's something nice to be said about that when something can always work. So this should be your second go round probably with the quadratic formula, I think. I'm pretty sure I do it every year in Algebra 1. And I say that not to sound like I don't know what I'm doing, but I know like with Sutter, we did it last year, but I'm not sure like with Ellie and you guys, did we do it a couple years ago? Yeah. So you're familiar with the formula itself. And again, what it boils down to is I'm always going to try factoring first. Because factoring, if I'm any good at it, is quick. Factoring takes 5 seconds or 8 seconds. The quadratic formula takes 45 seconds or a minute and a half. So everyone's always going to pick factoring if it's possible. But anyways, that's that. I've got some examples, and I tried to run through and pick examples that I thought would get you through your assignment pretty smooth. So if I skip something, or not skip, but if something comes up in the assignment that we didn't talk about, then just bring that to my attention. It's okay. So let's get to it. So here's our first one. So I look at this and I think, okay, for the first time this year, this isn't going to end well, but let's say I tried to factor. So if I were to try to factor, I would set up my shells like we've always done before. I would know, since 11 is a prime, that it has to go 11x and 1x, and I would know that they both have to be minus signs, right? And it doesn't take long to figure out that neither of these is going to work. If you put a 1 here and a 3 here, you get negative 34 x's in the middle. And if you switch the 1 and the 3, put your 3 here and your 1 here, now you get negative, what is that, 14? So you can't hit it. Like, it's not like there's like a trick to it. It's just not a factorable polynomial. So that's where the quadratic formula comes in and bails us out. And so, it's, again, not thinking you haven't done this before, but what's going to happen now is the polynomials that I'm going to give you, you're going to be able to get 2 of the zeros, 1, 2, or 3 of the zeros through synthetic division. And then I'm going to leave you at the end often with quadratics whose answers are going to be irrational or imaginary. And that's where the quadratic formula bails us out. So we're not talking about roots and zeros today at all. Today is just to practice the skill of using the quadratic formula. And it's not a one-day thing. We'll probably carry this over partially into Monday. So let's get to it. So you remember the quadratic formula, but before we talk about what the formula is, the a value is the number that's in front of x squared. Hopefully you remember that. The b value is the number that's in front of x. And then the c value is the constant term at the end. So clearly you see that one of the focus, or a major focus here, is going to be, we got to get everything in a nice standard position. So that'll become an issue in next examples, like some of the next ones. But for now, I just wanted to start us off where everything is in a row. We have our x squared, then our x, and then our number equal to 0. Perfect. Good to go. Do any of you by chance recall what the quadratic formula states? You don't have to sing it to me, but do you remember what the formula actually is? That's it. You nailed it. So it's one of these things that in the song, I know everyone, the song just seems to be like a thing. And the song isn't just to be cute and like ooh, let's have, I'm not into like the, ooh, let's have fun. It's just, it helps. It helps. I think anything you can come up with that helps you get something stuck in your head is a win as far as I'm concerned. And the song seems to do that. So yeah, it's the opposite of B, plus or minus. Then we want to draw a nice long square root sign. And inside of that, we're always going to take B squared and then subtract the product of 4A and C. And then when all of that is complete, we're going to divide it all by 2A. And since this is algebra 2, at some point, I'm going to show you where the formula actually comes from. I don't go down that road in algebra 1, no way. But with you guys, I'm actually going to show you someday that that's not just something that someone was like, oh, I think I'm just the gods are telling me. No, it comes from a very cool place, and you can actually derive it yourself by completing the square. It's really neat, but not today, and certainly not Monday.
But so, it's more fun to think that the gods just.
Yeah, I know that's what kids think. Like the formulas are just like just brought down from. No, they exist for a reason. Like people discover formulas; they don't invent them. So, anyways, that's the quadratic formula, and you definitely either want to commit that to memory or you want to have it always close by, like in a big old box. All right, so let's get to it. If we were going to solve this quadratic equation now, we're very meticulously going to plug those three numbers in place of A, B, and C. And so the first part of the formula states, I know we usually say negative B, I get that, and I don't care if you do, but that does not mean that the first number that we write is going to be negative. That's why you'll sometimes hear me say the opposite of B. Okay, so whatever B currently is, the first thing we'll do is switch his sign. So what are we going to write first? 10. And do not give me x's. X's are no longer a part of this conversation. When we are doing the quadratic formula, we are not concerned with x's. We are only concerned with the numbers in front of the terms. They're called the coefficients. Got it? So when we talk about what are we going to put first, right here, I'm pointing with a yellow arrow. Right there, we begin the journey. The opposite of B is 10. And then we write plus or minus. For this next step, I can tell you from experience that most of the mistakes will occur right here. Well, probably half of them, because a lot of times, first off, you're in high school, you should never use a calculator to square a simple number. But if you do, make sure you type it in correctly. So we're taking B now and we're squaring it. Just without a calculator, what's that going to be? 100. And again, you would be amazed if you came and sat on this side of the desk, how often a kid will put negative 100 there. And I can tell you exactly why that happens, because this is the knucklehead kid that typed this into their calculator. And I really would like to have this conversation now and never again. If you type this red box into your calculator, it will give you the answer negative 100. It's not messing up. What's wrong? Other than the fact that someone over the age of 12 is using a calculator for that, what's wrong with what they did, Bryce? It's only going to square what you tell it to. So if you want it to square negative 10, you need to tell it to square all of the negative 10, and then it will give you positive 100. Or on a much, much more intelligent level, let's talk simple common sense. What's going to happen when you square a negative number? Always. It's going to become positive, which begs the question, why even worry about the negative in the first place? So like if you asked me to square negative 13, I'm just going to, I mean, I wouldn't, but if I were a kid, I would type in just 13 squared because I know it's going to come out positive anyways. So I really would like that to be the last time we have to have this conversation. What I, in my long-winded way, am trying to tell you is right here where I'm pointing with a red arrow. Not all of you are going to hear this. Here it goes. That number is always positive. We clear? Okay. It's not up for debate. Good. So what's the first thing I'm going to put inside of my square root sign? Positive 100. Very good. So I'm going to put 100 right here. And you might remember this about me. I don't do this differently depending on what day of the week it is. I always put -4, and then I put 2 blank sets of parentheses, and I come back to this later. And if you ask me why, I'll tell you because I feel like it's good to go somewhere else and then revisit that area so that I don't put the wrong numbers in the wrong places. I found it to be beneficial personally. So I'm going to go to the bottom and I'm going to multiply 2 times A. What's 2 times A? 22. It is 22. Very good. And now I'm going to go backfill my A and my C values. What's A? And what's C? Good. Shame to make mistakes prior to where we're at now, because any mistake you would make prior to right now is just really not following directions. Like we haven't hardly done any math really. We squared a B. We took the opposite of a number, like whoop de do. Oh, and we did 2 times 11, but that doesn't count. So are we good here? All right, so this is where the lessons from the last couple days come in handy is, as you know, we're going to get a square root with a number that's um, needs dealing with, right, inside the square root sign. And that's why we need to practice that so we don't get bogged down. Next step is to work on the inside of the square root. By the way, I'm going to give you this word. I don't use this word a lot in Algebra 1, but all of this stuff in this purple box has a name. It's called the discriminant. And honestly, that word is derived from discriminate. What this purple box allows us to do is to discriminate. And by the way, I know that in American history, the word discrimination has a negative connotation, but you can be discriminating without discriminating against people based on their religion or the color of their skin. We understand that, right? So to discriminate is not to be a racist or a hate monger. It means to make decisions about things based on what you see, which again, in regards to humans is a bad thing. But as far as math is concerned, the purple box helps me to determine what kind of answers I'm going to get. If what's in the purple box is a square, like a 36 or a 9, then I can say that my answers are going to be rational. If what's in the purple box is a positive number, but not square rootable, then I can say that my answers are going to be irrational. And if what's in the purple box is a negative number, then I can say that my answers are going to be imaginary. So we are discriminating, like we're choosing what kind of answers we're going to have based on what's in the purple box. Got it? So that's what the name of that stuff, all that stuff inside the square root is called the discriminant. Now let's work it out. What is the value of the discriminant in this case? So let's work it out. We have 10 plus or minus the square root of what I hope is a basic math problem. When working the discriminant, you should always do what's in this little red cloud first. Order of operations, right? Multiplication comes first. So what's 4 times 11? And what's 44 times 3? 44 times 3? Uh-huh. It is exactly 132, right? 44 times 3 is 120 plus 12, which is 132. So the inside of the square root sign now says 100 minus the answer to the red bubble cloud, which is 132. Can you already tell from the discriminant what type of answers we're going to get? It's going to be a negative, so what kind of answers will we have? Very good, you guys. These are imaginary solutions. So what we're going to find are not actual places where the graph would touch the x-axis. They're mathematical solutions, but they don't touch the x-axis because they're imaginary. I did the numbers in the red bubble. 4 times 11 is 44. 44 times 3 is 132. Just multiplied the 3 of them together. You good? Okay, so let's head on down the road. So now we're going to work out the inside officially and say 10 plus or minus the square root of negative 32 all divided by 22. So this is where I stopped and said, okay, bless you, these kids have to get good at breaking down radicals. So hence assignments 15 and 16 in Delta Math. Practice, 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 practice 80 of them until you hardly think about it. How do I take the square root of negative 32 and break it down? I would take it in negative 1 times 16 times 2, right? If you did not do assignments in 15 and 16, then you get what you get. Like you should have practiced this a lot by now. And then I take the 16 breaks out and becomes a 4. The square root of negative 1 is my I. So my square root back in the quadratic formula part is going to be replaced with 4i root 2. So now I have 10 plus or minus 4i root 2 all over 22. Still with me? Good. And now we're going to do this triangle thing. You guys might remember this Dorito thing, like the Dorito of death. At this point, I like to draw like a guacamole colored Dorito and put it around these three numbers. I'm being very careful and meticulous with my pen to show you that I'm only enclosing the three numbers that are not included with anything else. Like just the numbers is all I'm interested in. Is there anything that all three numbers in the Dorito can be divided by? Two. You can only do this step if all numbers in the Dorito agree. If one guy goes outlier and says, I won't play, then we stop. You cater to that. So we're going to take all the numbers in the Dorito and knock them down by a factor of two. What do we get? 5 plus or minus 2i root 2 over done. So we can, as a final answer, say that these are the other two answers. You might say two. What are you, smoking the cracky whack? There are two answers in there, right? Because of the plus or minus. So one of the answers explicitly is 5 plus 2i root 2 divided by 11, and the other is 5 minus 2i root 2 divided by 11. And those are both imaginary. They're not on the x-axis. Got it? Let's go again, round two. Let's do 9m squared minus 4 equals 6m. What do you notice right away? Other than a different variable, like that doesn't matter. What do you notice? They're what? Yeah, it's not equal to 0. So that's going to become, I wanted to do that on like half of our examples today, just to make sure you're comfortable with that has to happen. So like who should move? The 6m should say, I'm coming over with you guys. Because if you remember me saying this, good memory, by the way, we always want this number to be positive, the number that's on x squared or whatever, we want that to be positive. The quadratic formula doesn't care, but you should, because it's going to be a little bit more annoying work at the end. So your mission is make x squared positive, and then everyone else comes to him. So in this case, I'm going to move the 6m across, and I'm going to get 9m squared minus 6m minus 4. You just tuck it right into that right spot. They got to go in that order. M squared first, linear m second, constant third, and now our a, b, and c are going to pop themselves out. So what's a? What's b? And c? There you go. Once you have your a, b, and c values, it's just now a matter of how willing are you to meticulously plug it in and not make mistakes. So let's begin. So when I write my quadratic formula this time, I'm not going to write x equals like I did last time. I'm going to write m equals because that's what I'm solving for is m. So here it goes. Who will go first? 6. Positive 6 because it's the opposite of b. Plus or minus the square root of what goes next? 36. And then I instinctively am going to put minus 4 blank blank and head downstairs. What's double A downstairs? 2a is 18. Remember, the bottom is always 2 times a. And what goes back up in the backfill, my parentheses? Good. We okay? I honestly, again, I would like to say I've done almost no math. Here are the three things I've done, and I don't consider any of them worthy of anything beyond like 6th grade. I took the opposite of negative 6. Okay. I squared negative 6 and got 36. And then I multiplied 2 by 9. So we're not allowed to get to this point and go, I don't know what's going on. Like it's just the formula plugging stuff in. Now, who remembers there's something strange about to happen? They don't. I'm going to point to something. Good. Who said that? Good job. This minus sign with the little red arrow pointing to it, he's about to change to a plus. And the reason is because if you take a subtraction and after the subtraction comes a negative number, you know that a minus a negative becomes a positive. And so what happens in a case like this is I actually wind up adding the answer to 4 times 9 times 4. Because the minus and the negative, they're going to find each other eventually. They're going to bebop their way and go bing and make a plus. So it's going to happen. Let's just do it now. So inside of the square root, the discriminants, we are going to have the square root of 36 plus what? 144. Good. And again, you can ask and you can keep asking, and I don't mind because I'll just keep telling you the exact same thing. If you say, where did you get 144? I'm just going to keep drawing this little bubble cloud and tell you once again, I multiplied those three numbers. And I don't mind, ask and ask and ask and ask, but that's what you do when calculating the discriminant is you multiply 4AC. And then all you got to worry about is the sign in front of him. Does it stay as a minus or does it switch to plus? Right, that's all. And if you can make it over that hurdle, now the rest is, just math. So we're now at m equals 6 plus or minus the square root of what? 180 over 18. Thank goodness that we are so well practiced on our roots. What would you break the square root of 180 into? Good find. And that might take some of you a lot longer than others, and it is what it is. But 36 times 5 is a good one to have in your notes. Like I would add that on, just like I had like 32 and what is it, 80, 48, those death numbers. I would probably add 180 because who in their right mind, any other than Coop over there, is thinking 36 times 5? Right? But that's what it is. So that becomes 6 root 5. So for my next line down in solving this quadratic, I now have 6 plus or minus 6 root 5. And it's time to draw the guacamole Dorito. They can all be divided out by 6, GCF'd by 6. And so if you take all three numbers playing nice together in the Dorito and divide them all by 6, what does the first 6 become? It does. Do I need that there? You do. The reason why we need that one there is because it's a placeholder. It's holding physically, it's holding down the fort for an entire position of an addition or a subtraction problem. However, on a related note, the second 6 becomes a 1. Do I need that one? I do not. The root 5 is like, I'm good. You don't need to multiply me by 1, thanks. And then what does the 18 become? That's it. Still good? Okay. I don't intend to bore you with a bunch of the same thing. I tried to pick examples that felt like they provided different opportunities for discussion. Are we going to do all 8? Probably not. That'll be a bit much, but I'm going to go at least a couple more. And you don't have to do this over the weekend. You'll work for 15 minutes or whatever, and then we'll work on Monday. Did you just say good? Can you what? You can after this next example, just because this one provides something a little unique, and everyone's going to say, what do I do? So let me get through this one, and then let me give you one to do on your own. Deal? Okay. So for this one, we have 5x squared minus 7x equals 6. What's the problem? Right away. Yeah, the 6 is not behaving, is not cooperating. So basically, we take the 6 and we subtract it over to the left and reset it equal to 0. That's just step 1. You don't always have to do it, but if you do, it's not up for debate. What's A? B? C? Okay. So how about this, to what Javin said, how about you guys work the first step, and don't look up at the TV and by the first step, I just mean let's plug everyone into the formula and get to that first spot where we start making decisions. once you're ready, and you might have gone a step further than maybe I went, but this is what it should look like in its brand newness. Good. So the question at this point, 100% of the time is going to be, what is the fate of that sign? If you don't ask that question, you're going to probably miss half the problems. Is he going to stay a minus or switch? He's a switcher because he's going to encounter that negative later on down the line, right? So one thing you can do to make your life really easy is as you work the problem, you can do this. You can just take the negative off the 6 and change the minus into a plus. That might simplify things for you. If you know it's coming, you might as well do it now. All right, as far as the next step is concerned, we're going to head on ahead and do 7 plus or minus the square root of, and I feel like I can probably do 2 steps at once here. 4 times 5 is 20, 20 times 6 is 120, and 49 plus 120 is 169. And the reason I wanted to do this example with you is because of what's about to happen. And then after this, I'll let you try one without me. What is significant about the discriminant in this case? It's a square. So I'm going to get rational answers. And there's an upshot to that, like it means something. But you should know, again, from days of practice on this, that the square root of 169 isn't just another square root. It comes out to a whole number, 13, right? I don't need a tree. I just need to know what it is. So where I'm at in the process now is 7 plus or minus 13 over 10. Now, to unveil the answers, what we have to do, and you'll hear me say this a lot, is trace the pathways. There are 2 pathways now open to me. And I don't usually go down these pathways because I can't, quote unquote, do 7 plus the square root of 5. You leave it like that. But I can, because I'm a big kid, I can do 7 plus 13. What is it? It is 20. It is explicitly 20. So one of my answers, if I follow the red pathway, 7 plus 13 is 20, and I stick that over 10, and what's 20 over 10? So one of my answers is x equals 2. 20 divided by 10 is 2. Got it? Now the other pathway, I'm going to circle him with a different color, is I go reset and I say back to the beginning. I'm going to take the other road this time. What is 7 minus 13? It is negative 6. And I put that also over 10. You see? And this is not optional. Like we tell you when your answers are going to come out rational, we need you to go all the way and get them out and expose them each as who they are. So what is negative 6 over 10 reduced to? That was interesting. Negative 3/5. So my other answer is x equals negative 3/5. I've asked this question before, but it's been so long. There's no reason you should know this. But the fact that I got answers like this, what does it mean? Well, go all the way back to the beginning of this problem. It means that we didn't need to use the quadratic formula. Good answer. I like that answer. So in hindsight, here's the thing, and I wanted you to see this because it will happen to you a couple times in your assignment. And when this happens, it doesn't mean you did anything wrong. My expectation is that on every problem in the thing we're going to work on the next couple days is that you're going to go in and use the quadratic formula 100% of the time. Like I don't even expect you to check for factorability. But when this happens to you, just know what it means is, snap, I could have factored. And that will not, it's not supposed to make you feel regret, like, oh, why did I do that? It's just supposed to be kind of an eye opener, like, oh, I could have done this differently. So look back at the original problem, if you'd be so kind. And now that we know what we know, looking at it in hindsight, and we realize now we could have factored it like this. And look, and you can think about it as what were the answers? Well, the answers were 2. So I know my second factor has to be x minus 2. So by default, my first factor has to be 5x plus 3. And you can check it yourself and like, I'll be darned. Look at that. Sure enough, there's my 3x minus 10x. Aha. So those answers kind of reveal themselves and make you kind of go back and think, could have done it that way. Okay. So I haven't shown you everything that I want to, but like Javin said, I think it's a good idea now for me to let you try one without me. So I'm going to put a problem on the board, and then I'm going to work it out on the board, and I'm going to turn off my TV while I do that, and then we'll take some answers when you think you're ready.
And then writing the answers is like when you watch graphic things, try and make it drawing. Oh,
Yeah, for a second, I did not know what you were talking about, but I'm picking up what you're putting down. Oh man. See, these are all like new. Okay, I'm just putting this on the board. Okay.
Is your brain a little foggy?
Oh my God. Speaking of foggy, it was a little foggy out there this morning for the drive to work.
It was nice.
Nice. There you go. ¿Qué podemos hacer para hacer este problema más fácil? Do you see anything?
Yeah,
Right. So you guys should all be leaving the 12x squared right where he is. And Corbin said it exactly the way I try to say it. You don't listen. If you're the kind of person who thinks I'd rather move one thing than two, you got to get over that with this, because I get that it would be more efficient to move the 12x squared to join his homies, but then he goes negative. So 12x squared's like, dudes, I am here. You suckers come my way, because I'm positive. Now, that is not what I meant when I said, do you see anything? I'm trying to help you out here. Ulysses S. Hot Streak over here. Say it again. What is it? I'm telling you, you're going to enjoy the next 4 minutes of your life a lot more if you divide all the numbers by 6. Let me get you, I just want to get you started. That promise, Jav, and then I'll get out of the way. So first off, when we set it up, it is 12, is an ugly 2, 12x squared minus 6x plus 12. So did y'all get this far?
Yeah.
Now, do you notice that you can divide? Watch this. Divide everyone in the equation by 6, and what are you left with? Now, I will get out of the way and let you work that problem. But you're going to enjoy the process way more with your A, B, and C being 2, -1, and 2, as opposed to 12, -6, and 12. Have at it. Swaggy B, did you finish already, bro?
Yes.
All right. I'm going to pause L recording. Yeah. Once you're committed, check and see how you did. This is the first problem in our notes today where there's really no meat on the bone. Like, you do the formula and then you just stop. Why am I done in the purple box? 15's a dead root. Right. Yeah, you could break it into 3 and 5, but you wouldn't, because that'd just be weird, right? Shavin, did you get it? You guys have any questions on that one? Austin, you good on this one?
Yeah.
Tinsley, good. Serenity, good. Erica, did you get it? All right, let's go again.
I have colors.
Go ahead. Come on, let's go. Back on task. Try this one. Tristan, what's up? Yeah, this problem made its way onto my note card today for only one reason. And it's exactly what Tristan just said. You should notice there's something missing, right? There is no middle term, B. So what is B? Right. You can't ignore it and act like it's not there. B is 0. It's important. Now, there are going to be times where, like throughout the formula, the zeros are really not going to wind up mattering, but structurally having them there helps.
So if we have that, you know, that right?
Mm-hmm.
Yeah.
So before I do hardly any math at all, this is what it should look like. So my question to you becomes, what purpose does the first 0 serve? Placeholder, but really at the end of the day, like what's 0 plus 4? What's 0 minus 4? Like, so you already know what the answers are going to be. Like the 0, it turns out it serves really no structural purpose in this case. So even though I would tell you that you have to acknowledge that it's there, this 0, I hope you agree, really serves no purpose. Yes, Chad? Are you talking about where my little arrow is pointing right here? If there's another negative to be found somewhere down the line in this pathway. So the thing I just underlined in red, if you find another negative in there, then it's going to turn to plus because a minus hitting a negative turns to plus, right? Got that? If it's no negative, it stays a minus. But in this case, like the minus that my arrow is pointing to is going to switch to plus. Because this minus that I'm circling in purple, whether you like it or not, he is eventually going to encounter this negative. Do you understand, as those numbers plow together, that eventually they find each other and two negatives multiplied together make a positive. So I will only change that minus into a plus if I encounter a negative in that clump after the minus. Got it? I would also ask you this. What purpose does the 0 inside the square root sign serve? None is the right answer. So we wind up with this. If you guys listen, I know you're working back there, but I'm still trying to do my job. So give me just a few more minutes, please. So we wind up with x equals positive negative square root of, I'm sorry for the big numbers. I have to use a calculator because this is way outside my comfort zone. 912, exactly. So we have the square root of 912. This structurally feels different to me because I don't have a number in front of the plus or minus sign, right? We agree? Yeah. And did you already break down 912? 16 times 57. Good find. So if I took the square root of 912 Sutter has gone ahead and helped us out with the grindy part of this. And the best strategy with a number like that is probably, yeah, to divide it by 2 or 3. And when that fails, then just start hammering through your red list. Divide it by 4, divide it by 9, divide it by 16. You're like, hey, it works. So what do I replace my square root of 912 with? Good. So my answer in its current state is x equals positive or negative 4 root 57 over 24. And there is no Dorito this time, FYI. So we don't have to have 3 numbers agreeing. This time only 2 numbers have to play nice together. And the Dorito kind of morphs into this like Frito looking thing, like this strip. And can those numbers both be reduced? Yeah. So we wind up with x equals positive and negative, positive or negative, root 57 over like that. You guys feel like you can take the ball and run with it from this point? Yeah. So your delta math, as you know from whatever, it's on, and I don't. It's a lot, and it's going to look different. It's going to look really weird because there's like problem number 1 and number 2, and the reason is because I wanted you all to do the same problems. I noticed if I just left it up to delta, that it seemed like they were giving you too many softballs to hit, and I didn't want that. I don't want to insult you with that. So I went through and I picked what I thought were good problems, and I said assign this to everyone, assign this to everyone. So you'll be doing the exact same 28 problems or whatever as everyone else in algebra 2. Got it? But that's why it looks weird, is because when I pick problem by problem by problem, the assignment looks really long, but it's just the same. Let's see if we can get a couple done before the bell rings. Yeah.